Welcome to C Note. In this video, we'll first understand Ohm's law, and then learn how to find the equivalent resistance of resistors connected in series and parallel. When a voltage, potential difference, V is applied across the ends of a metallic conductor, as in figure, the current in the conductor is found to be proportional to the applied voltage. If the proportionality holds, we can write V equal IR, where the proportionality constant R is called the resistance of the conductor. Now let's explore two main ways resistors can be connected in a circuit. The first one is a series connection, and the second one is a parallel connection. In a series connection, the same current flows through each resistive device. In a parallel connection, the same potential difference is maintained across each resistive device. However, the current divides among the branches, the total current is split, and each branch receives a portion depending on its resistance. Let's understand resistors in series. When resistors are connected one after another, like this R1, R2, and R3, they form a series connection. In this type of connection, the same current flows through all resistors. Each resistor causes a voltage drop, so we get V1 equals I times R1, V2 equal I times R2, V3 equals I times R3. Adding all these voltages, we get V1 plus V2 plus V3 equals I times R1 plus R2 plus R3. If we replace all the resistors with a single equivalent resistor R, then V1 plus V2 plus V3 equals I times R. Comparing both equations 4 and 5, we get the formula for equivalent resistance in series. R equals R1 plus R2 plus R3. So, in a series circuit, resistances simply add up. Let's solve an example to find the equivalent resistance of resistors in series. We are given three resistors, 1 ohm, 5 ohms, and 8 ohms, all connected in series. In a series connection, equivalent resistance is the sum of all individual resistances. That is, 1 plus 5 plus 8 is equal to 14 ohms. Therefore, the equivalent resistance is 14 ohms. Now let's look at resistors connected in parallel. In a parallel circuit, all resistors are directly connected across the same 2 points of the power supply. This means each resistor experiences the same voltage, which is marked as V in the diagram. However, the total current, I, from the battery splits into separate paths, I1, I2, and I3, for each resistor. According to Ohm's law, current through each resistor is I1 equals V divided by R1, I2 equals V divided by R2, and I3 equals V divided by R3. This means the current in each branch depends on its own resistance value. So, the total current I is the sum of these three. I equals I1 plus I2 plus I3. Substituting the current values, I equals V times 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Now, if R is the equivalent resistance of this parallel combination, then according to Ohm's law, I equals V divided by R. Now, let's equate equations 4 and 5. V divided by R equals V times 1 divided by R1, plus 1 divided by R2, plus 1 divided by R3. We can cancel out V on both sides, and we get the final formula. 1 divided by R equals 1 divided by R1, plus 1 divided by R2, plus 1 divided by R3. This is the key formula used to calculate the equivalent resistance in parallel circuits. Let's solve an example to find the equivalent resistance of resistors in parallel. We are given three resistors, 1 ohm, 2 ohm, and another 2 ohm, all connected in parallel. The formula for resistors in parallel is 1 by R equals 1 by R1, plus 1 by R2, plus 1 by R3. Substituting the values, 1 by R equals 1 by 1, plus 1 by 2, plus 1 by 2. That gives 1 plus 0.5 plus 0.5. So, 1 by R equals 2. Which means R equals 1 by 2 is equal to 0.5 ohms. Therefore, the equivalent resistance is 0.5 ohms.